Okay, welcome to the February 2014 Mississippi PowerShell User Group meeting. This is our 12th meeting. We started last March. This month, Ron Edwards is presenting on managing access control in PowerShell. For those of you who don't know who Ron is, he's the co-founder of the Mississippi PowerShell User Group, and he was the winner of the Advanced category in the 2012 Scripting Games. Ron, I'll go ahead and turn it over to you.
All right. Thank you, Mike. So, like you said, today I wanted to talk about managing access control with PowerShell. I've got a few, very small number of PowerPoint slides. I want to cover those just to kind of, I'm not a huge fan of PowerPoint, but I did want to cover a few of the terms that I'm going to be using, make sure everybody knows what I'm talking about. If you have any questions at any time during the meeting, feel free to type something in the chat window. Mike can interrupt me, or there's I actually wouldn't have a problem if you just unmuted your microphone and asked me directly. So let's go ahead and get through some of these slides, and then we'll start doing some demos. So when we talk about access control, we're usually just talking about two things mostly: who is allowed to access securable objects, and when I say securable objects, I'm talking about things like named objects, files, registry keys, services, printers, WMI namespaces, anything that you access via a path or a name. There's also some unnamed Windows objects that are securable objects, threads, Windows stations. There's a whole ton of stuff that is probably way over my head. But the other thing, when we talk about access control, we're talking about what types of access can generate security auditing events. Let's say that you're interested in who touches a specific file, or you're interested in whenever there's a failed access attempt to a certain resource. Maybe somebody tries to stop a service. You're interested in that. You can control that through access control. All of this is controlled using what are something called a security descriptor. And a security descriptor really consists of four things. It's this binary structure, and it contains an owner. It's a security identifier for who actually owns the security descriptor. They get some special privileges over it. There's a group. You don't really have to worry about the group so much. I think it was used mostly for POSIX support, but you can just act like the group's not there, but there is a group that is contained in a security descriptor. And the two big things: the discretionary access control list, which controls who is allowed to touch whatever object the security descriptor belongs to, and the system access control, which controls the auditing and what types of access generate the auditing events. The discretionary access control list, you'll hear me call that the DACL, and the system access control list I will call the SACL. So both of those access control lists contain just a list of access control entries, or an ACE. And an ACE consists of a principal, sometimes you'll hear it called a trustee. That's the user or the group that the ACE applies to. You'll also have an access mask. That's a 32-bit number that controls the privilege. So, when you hear somebody talk about full control over a folder, that full control is actually translated into a numeric access mask. And we'll cover a few of these access masks in some of the demos. The access control list also has a type. There are two types allowed in a DACL. That's allow access and deny access, an ACE for a DACL. And there's one that's allowed in a SACL. That's a system audit type. And each ACE also contains inheritance information. Who, like if you're talking, that mostly applies to things that have like a hierarchy. So a folder children under the folder, sub-child objects like subfolders or sub-files can inherit the information from their parent. So now we're going to move on to different ways to manage security descriptors outside of PowerShell, and we'll mention PowerShell. The first one that everybody should be familiar with is called the ACL Editor. That's what you use from the Windows GUI. From the file system, if you right-click on a file or a folder and go to Properties and then go to the Security tab, you can see the you see the DACL by default, and if you click on Advanced, you can go in and see the security access control list to view the auditing events. You can see it for the registry. So the pros of using the ACL Editor, obviously it's very easy to use. I'm sure everybody that's watching this has used it before. The information's all presented in a very clean, neat way. You can see there's a simple view and an advanced view for the discretionary access control list. But the problem with it can't really be automated. And there's also a lot of objects that Windows just out of the box won't let you touch. You can do files, folders, registry keys, printers, but there's not really an easy way to do service access control. You can't really control processes. There are other utilities that let you do it. Process Explorer, I actually wasn't aware of this until fairly recently. You can view service security descriptors using Process Explorer. You can also see a process, like a running processes security descriptor from Process Explorer. Let's move on. There's also third-party command line utilities. iCackles, Sub and ACL. There's a whole slew of third-party non-Microsoft utilities that you can also use, and the nice thing about those, they can be automated. You can come up with a command, craft a command, put it in a batch file or a PowerShell script, run it on another computer. You can handle more objects than the GUI can handle out of the box. But the problem, sometimes they have really weird, obscure syntax, and the syntax is different between the utilities. I've always had to bring up the help to figure out how to really do anything. And if you're trying to get information from them, they're gonna output text. So if you're not just gonna read it right there on the spot, if you want to save it for later, maybe put it in a CSV or something like that, you have to do some parsing. And that's nobody really likes that. That's not too fun.
Hey Ron.
Yes.
Hey, what's iCackles? What's that stand for?
I don't know. That's just one of the utilities. I think it's iCackles, isn't it? Hold on.
Yeah, I've actually used iCackles, but I'm not aware of what it stands for.
Yeah, I'm not sure what it stands for. I mean, the obviously ACLs is in the name, but I'm not sure what it stands for. But there are a whole slew of third-party utilities out there that will let you modify these things. So then we're going to move to PowerShell, and there are, I'm sure, other ways besides the third-party utilities, the Windows GUI, and PowerShell. But these are the three ways I've worked with security descriptors in the past. PowerShell is going to let you. There are different ways from within PowerShell to work with security descriptors. You can use WMI. There's a set of WMI classes that let you view and modify security descriptors. There are .NET objects. You can work with those directly. You can use the native commandlets, get ACL and set ACL. You're going to have to. Those are just going to use the .NET objects, and to use those, you're going to have to dip in a little bit and use some .NET objects yourself. And there are also add-on modules, one of which I've created, and I'm going to cover somewhat tonight as well. Another good thing about those, everything in PowerShell comes out as an object. So, if you're using the native commandlets, the .NET objects, WMI, anything I've just mentioned here, your output should be an object. So you should be able to fairly easily, come up with something to export it to in a form that you can then import later. So just like with the third-party utilities, the command line executables, you can use the PowerShell commands to automate making changes, and you can make changes on a large scale at the same time. And just pretty much one of the same cons as the third-party utilities. You've got the learning curve and learning the syntax for the different methods. So today what we're really going to cover are using the native commandlets / .NET objects and a module that I've created that I call the PowerShell Access Control module. So the PowerShell Access Control module, one of the things I like about it, it will work with more objects than the native commandlets. The native commandlets really just work for files, folders, registry entries, or registry keys. They with PowerShell version 3, they work with a few more objects, I believe, but you have to have already gotten the object and then you call that. I'm actually not sure how to work with some of it, but I mean they don't work with like services and processes and things like that. My module does address some of the bugs with the native commandlets. The set ACL commandlet is problematic. There are a lot of scenarios where it doesn't work exactly how you would expect it to. I'm going to cover some of those tonight as well. And it's available on the Microsoft Technate Gallery. So if you're interested in it, you can search PowerShell Access Control module. We can put a link to it up on the website as well. And with that, let's go into some of the demos. All right, give me just a second. And somewhere. All right. First, let me make sure yeah. All right, so some demos. First, I wanted to kind of cover, first of all, are there any questions before we get started with the demos? All right, I'm going to go ahead and jump right into using get ACL, which is a native PowerShell commandlet. If you open up PowerShell, you have access to this. So we're going to, in this example here, we're going to create a folder, or actually a folder's already been created. Let's see. And we're going to run that command. And by the way, can everybody see, is the font size, is that a good font size? All right, so now if you take, we assign the output from getACL to the ACL variable, so now we can take a look at the ACL variable. You can see that the default format, it's going to bring it up as a table. You can see the path, the owner, and the access kind of starts to run off the, outside of that column. So you can pipe it through to format list, and it'll show you, it'll look a little bit friendlier. You'll see the the path, the owner, and the group, and the access is a little bit friendlier now. It's not running off the, you can see all the aces right there for the discretionary access control list, and you can see the STDL format. Now the access, there is more information. That's just kind of like a friendly view there to show you the principal, the rights, and I guess. And it's all, so the principal, whether or not it's allow or deny, and the rights. So if you actually look at the access list itself, you see a little bit more information. Now, by default, it's showing it formatted as a list. You're probably going to want to format it as a table. So when you look at it formatted as a table, it's pretty useful information there. You can see the rights. And again, it's not wrapping them, so this last one right here, you can see that it's got execute and synchronize for the users group, but it kind of runs off. Same thing with the inheritance flags and the propagation flags. So that is what it looks like with getACL. Now I want to show you from the PowerShell Access Control module, you've got the function called getSecurityDescriptor. So we're going to run the exact same thing we just ran, except instead of using getACL, we're going to use getSecurityDescriptor. So by default, the view for that I think is a little bit friendlier when it first comes up. It's not showing the owner right there, but it's showing what it applies to, and then you can see the DACL over here to the right. So if you format it as a list, you'll get a little bit more information. And one thing I did want to note, so we're not seeing the SACL right now, and that's because I didn't specify the audit switch. So to actually view an object's security access control list, you actually do have to have a special privilege that has to be, you have to have a special privilege assigned to your token, and it has to actually be enabled. So, a regular user by default, unless they've been given the special privilege, they can't even view the SACL. So when you call get ACL or get security descriptor, by default it's not even going to try to get it. But if you call it with the audit switch, you will get the SACL, and we'll do that in just a second. But to me, again, I like the output of this a little bit better than the default get ACL. So same thing though, you have the access list. When you actually call the list itself, it shows the information. Now, let's bring up the ACL, get ACL's access list, and you'll see, hold on, format table, I keep forgetting to do that. And then, so on, all right, I promise I'll get this right at some point. There's the get ACL, and here is get security descriptor. And notice, by default it's doing the table format. You don't have to pipe it to format table. It'll do that automatically. So the biggest difference here is that, first of all, the writes will wrap. So you see this bottom one, read and execute and synchronize. It does actually wrap. But you'll see that instead of showing inheritance flags and propagation flags, I have these two things here, applies to and only applies here. So if you were to use the ACL editor to show you information about an access control list and about each ACE, it'll tell you, like for a file and folder, it'll tell you if it applies to the folder, subfolders, and files, or maybe it just applies to the folder itself. So what this applies to is showing you is that each of these ACE entries apply to the object. So in file system terms, the object itself is the folder, the child containers, subfolders, and child objects. So if you pulled this up in the ACL editor, it would say that each one of these ACEs applies to the folders, subfolders, and files. And I mean, that's the same information that the inheritance flags and propagation flags are telling you up top. But to me, this is a much friendlier way to view it. It seems, to me, it makes a little bit more sense. And the only applies here, you can have it to where an access control entry only applies directly to child items, and grandchildren it won't apply to. So, a subfolder of a subfolder it wouldn't apply to. And that's what the only applies here. Again, the ACL editor shows you that information. So, let's, real quick, we'll go through the audit. So, now you can see when we did call get ACL with the audit switch, you can see audit entries. And same thing when you call get security descriptor. You can see the audit entries. So you can see that, audit failure, everyone, full control, and audit success and failures for everyone, full control. So that's the, just the basic viewing security descriptors using get ACL and get security descriptor. Now I wanted to cover, so that, if you wanted to use that to export a bunch of security descriptors, the main problem with that, so you have this object, we'll look at the security descriptor, the one that came from get security descriptor. Again, we're looking at it here formatted as a list. So you have this object that contains the path right here that tells you what these things apply to, and then you have another object that contains the DACL and another object that contains the SACL. So if you tried to export that out, you'll end up, let's say you put it to a CSV. Two of your columns are going to be these access control lists, which contain, an unknown number of access control entries. That's really kind of a problem. It doesn't let you, let's say you're, you want to view all the access control entries that are not inherited, and you want to save that to a CSV. So if you were to, take an entire folder structure and export all of its security descriptors out to a CSV, what you got using get security descriptor and get ACL wouldn't really show you, it just wouldn't be in a very easy format. So get access control entry is a function from the PowerShell access control module, and it'll show you, it basically takes every one of the access control entries and attaches the path to it, so that you now can get a CSV that contains all the access control entries you're interested in. So let's see. Here we're going to, that same folder we were working with earlier, if we run get access control entry on it, and hold please, let me specify it. Try to run it again. So you'll see, this looks like we got the security descriptor and then just extracted out the access control list. This would also work with the audit switch. So it's showing that same information, and you can see that the display name up here is being shown. So this is nice because now you can dir so you can see that calling get access control entry on this folder here, it shows, so I guess there were two, there's a file and a folder, so it's showing all that. You could have called the recurse switch. You can see the file applies to only the object. That's because it's not a container, that's all it's going to be able to apply to. If you call get member on this, you can see that it contains, so if you were to export this to a CSV, you would get an access mask, the ACE flags, the ACE type applies to the path. So this would give you a way to save all of the access control entries out from the DACL or from the SACL. You can also, let's see, you can search just on where ACE type is denied. You could also do it where ACE type is denied and the principal, well, I guess we're only going to see denied entries for guests. So you could just say where the principal is users and the access mask, let's see, folder rights modify. So anywhere where users have at least modify rights, and you can see that it's filtered it just on that. There's a not inherited switch, an inherited switch, things like that. You can really, there's a lot of parameters you can pass to it to filter just what it is you want to see. You could do the same type of thing for the registry. Let's actually get rid of that. You can call it against a service. So let's look at the bit service. So you can see the access mask, and this access mask changes depending on what the device is. Full control for a service isn't necessarily the same access mask as full control for a file and folder. A file and folder doesn't have a start and stop enumeration in their access mask. You can look at this right here. This command is going to bring up the first two device drivers on the system and get the access control entries on those. We can look at printers. That was get sim Win32 printer. If you have a Windows 8 machine, get printer. And again, we'll do select first one and get access control entry. And you could have piped that also to get security descriptor. WMINE namespaces. So this is for the the system security shows the namespace security for, in this case it'll be the default namespace, the root CIMV2. So you can audit that as well. Process. Let's do get process ID. So that's for the currently running process, PowerShell ISE. You can see that system and administrators have all access, and this is actually what's called, this is a session SID. So the system, it's assigned at the session. So that's normal that it actually can't translate that into an account. So that's get access control entry. You can use that pretty much for auditing. So if you wanted to do that using get ACL, it can be done. You can make a little one-liner that'll do it for get ACL. You just basically use add member to add the path onto the whichever access control list you're interested in. So let's move on now to modifying ACLs. So first we're going to make 3 folders. There's a Get ACL folder, a Get Security Descriptor folder, and a Get Security Descriptor Quick folder. Now I'll explain what the quick means in a second. There should be some prompts here. Yeah, hold on. This is basically to delete and restore and create a new folder. So first let's go through Get ACL. This is how you would add an access control entry with Get ACL. So the first thing, you need to get the security descriptor by calling Get ACL. And the next thing you would do, you create an ACE. So for a file and a folder, you use this file system access rule object. To show you real quick, like you could look this up on MSDN somewhere. You could use the PowerShell help. They have an example of it. You can also use some reflection to see what it is you actually need to create. So in a second, you'll see that we're going to use the add access rule method. So if you call that, you can see that add access rule expects a system.security.accessControl file system access rule. So if you were to put that type into PowerShell and call the get constructors on it, and for each one of the constructors convert it to a string, you will see that basically the constructors for it, there's a few different constructors, but this one would take an identity reference. That would be for your principal. This one takes file system rights. That's going to be the enumeration for the access mask. So that's essentially what we're doing here. We're creating an access control entry. There's a user called limited user on this machine, and for the file system right modify and the inheritance flags we're going to assign are container inherit and object inherit, and the propagation flags are none. So what this means is that this will apply to the folder, subfolders, and files. It's it's not the friendliest way. If you want to apply it, and if you were applying this to a file, you could not have those inheritance flags on there. I believe it would actually give you an error if you tried to have those inheritance flags and assign it to a file. And this is an allow ACE, so we supply that as well. So if we run that, we now have an access control entry assigned to the ACE variable. And then we call the add access rule, and it will assign it. You can now look. You can look real quick. So we've modified the security descriptor, but we did not apply it yet. So in memory, the ACL object is the security descriptor that we just modified. But if you call, get access control entry on the folder, you'll see that basically we have just inherited permissions. If you look over on the is inherited column, everything's inherited. There's an allow, deny. They're all but one of the ACEs are allow entries. So now we're going to call the set ACL. So after calling that, when we call get access control entry again, you'll see our new ACE added. It's not inherited. There you see the modify. You can see applies to, again, since this is using the get access control entry from the PowerShell access control module, you don't have to worry with the inheritance flags and the propagation flags. It gives you this applies to column, and the shorthand shows you that this is applying to the object, child containers, and child objects. So real quick, I'm going to show you, so using the PowerShell access control module, you can actually use it and use get ACL and set ACL at the same time. So that .NET object we had to create earlier using new object, making that ACE, you can actually use a function called new access control entry from the PowerShell access control module. And by default, if you give it, if you pass the parameter for folder rights, file rights, or registry rights, it will output an object that can directly be used with the get ACL object. So if you were to create this quick ACE here, you can see there's quick ACE, and let's look at its type. It is a file system access rule. If you look at ACE, the original one we created earlier, First, let's look at it. I mean, it is the exact same ACE, and get type. It is a file system access rule. So new access control entry. I mean, to me, that's much easier to create. New access control entry. You could alias it to new ACE. You give it a principal, and you tell it folder rights. New access control entry actually has a ton of dynamic parameters. It looks at any of the custom access mask enumerations that have been defined, and it gives a dynamic parameter for each one of those. And it also has folder rights, file rights, and registry rights hard-coded in as normal parameters. If you pass it folder rights, then it defaults to setting the inheritance and propagation flags to apply to the folder, subfolder, and files, the same way that the ACL editor would. So that's the only real difference between using folder rights and file rights. Obviously you get IntelliSense, so principal everyone, and we'll say, you can see that you've got file rights, folder rights, registry rights. You can come down and see the other types of rights. Let's do folder rights real quick, and immediately the actual rights come up, and this would work. You could tab complete in the console, but we want to give, let's say we want to give everyone the create files right. So then what we still have left, we have ACE type. So we could make this an access allowed ACE, access denied, or system audit. If you don't supply anything, it'll default to an access allowed. So let's actually make it denied. And you can change the applies to. We could say we only want this to apply to child containers. And so if you were to put that out, you can see that it creates a file system access rule, create files. It's a deny rule. It applies to everyone. And the inheritance flags, earlier you were seeing the propagation flags were none, and inheritance flags were container inherit and object inherit. So anyway, let's now move on. We're going to come back to that in a little bit, but you could use the PowerShell access control module and still use get ACL and set ACL. But let's show how to do it using get security descriptor and set security descriptor. It's literally going to look, you can make it look the exact same way that the same steps that you use for get ACL. You can call get security descriptor, and then you can modify the security descriptor and then save it out. So you can read here. You can pick any of the following commands. They'll all do the same thing. So we have some shorthand things we can do. There's another function here called add access control entry. So we created the quick ACE earlier. So you could call, you could pipe the security descriptor to add access control entry, and you could give it the quick ACE, and we're going to say what if, so it'll tell us what it would have done. So you can see that it would have performed the operation of adding the ACE and on that object, the in-memory security descriptor. Another way to do this, instead of defining the quick ACE earlier, add access control entry actually, this module makes extensive use of dynamic parameters. So add access control entry actually has a couple of its own parameters, and then all the other ones come from new access control entry. So anything that, any way that you could create an access control entry using new access control entry, you can also create it using add access control entry. So you take the security descriptor, pipe it to add access control entry, tell it the principal is limited user, folder rights are modify, and again we're going to call it with what if, so it's not going to actually make any changes to the security descriptor. This one I think is pretty cool as well. So earlier, we were working with the ACL object. That was what came from get ACL. We can pipe that to get access control entry, and we can tell it we're looking for the principal of limited user. So you run that, and it returns this one ACE. Well, you could then pipe the results of that, back to add access control entry, and you tell it the security descriptor object is SD. That's what we were working with earlier. So you can see the what if, it's going to do the exact same thing. It's going to add a single ACE for that. But you can also, if you're familiar with the get ACL, then use the method on that object and then save it out. You can still do sd.addAccessRule. This is the way that you would have done it with get ACL. And there is no what if on that. It's a method. So we'll actually use that one. That one made it permanent or that one affected the in-memory security descriptor. If we look at the access list now, or the discretionary access control list now, you will see that we have one entry that is inherited. And then we'll save it. Now, by default, set security descriptor is actually going to prompt. You have to call it with the force command to not make it prompt you. When you run that, you'll see in the console this looks a lot better because the way the font is, it is, you know, everything lines up properly. But you can see that it's telling you exactly what it's going to do. It's going to set just the DACL, and there's a control flag called unprotected DACL on here that says that inheritance is enabled. So we'll say yes. And now we'll call get access control entry on the actual folder, and you'll see that it was in fact saved out. So, you know, and then earlier, you know, we made another folder called get SD quick folder. So we'll look at the access control entries on that. You'll see that it's just like the other ones before we started. They have only the inherited entries. And you can do this, you know, the add access, all of these things that take a security descriptor actually, you know, will take all kinds of objects as input. You know, if it has like a path property and you feed it to it, that's enough. It'll take the path off of it and attempt to get a security descriptor out of that. So here, you know, I'm showing you, you don't even have to call get security descriptor. You know, you call get item on that folder and then pipe that into add access control entry. Give it the principal, folder rights. You know, again, you could pipe in ACE type if this was going to be a deny or an audit. Now, by default, since we're not passing it an in-memory security descriptor, by default, this is actually going to call set security descriptor for you. So if I were to call this, I'm just going to highlight the part without the force, and you'll see that it prompts me again. I'm going to say no, I don't want to say that, and we'll call the whole thing with the force in just a second. So there we go. Now we take a look. You'll see that it did in fact save that out. So now we should be able to compare the STDLs, the string representation. So if we run all three of these with any luck, they will all be identical. I know that looks like gibberish there, but you know, your eyes should be able to show you that they do match up. There's the first one, there's the second one, and the third one is below that. So they're all the exact same security descriptor. So I mean, does anybody have any questions at this point about modifying? I don't think that I cover, I don't think I have anything set up in the pre-made demos. I mean, we can cover it a little bit later on removing ACEs, but it's pretty much the same thing. There's a remove dash access control entry. So, you know, if you're looking for, like, it removes an exact ACE, so you feed it the right parameters and it will find that ACE if it exists and remove it. If you're looking to do searching or something, you can call get access control entry, give it whatever you want to filter on, and then pipe that into remove access control entry. And I see some people are typing, so I'll give them just a second. All right, I'm going to go ahead and get the next demo set up. So here I wanted to talk a little bit about inheritance. So, all right. Will your module work with the Active Directory provider? Actually, Tim says anything is better than using those .NET commands. I agree, and that's where, you know, the new access control entry was. I made a function for that a long time ago that did file, folder, and registry entries, and then I added the service stuff in. But to answer Matt's question, will it work with Active Directory? So I was going to mention that a little bit towards the end. Right now, as it is, no. You can actually get the, you know, using this security, the get security descriptor, you can get the security descriptor off of an Active Directory object. The thing about it is, though, Active Directory objects have a slightly different security descriptor type. Their ACEs contain more information than what I was talking about. They actually have these object properties. The plan is to have the module work with that at some point in the future. That may be a couple of weeks from now. That may be a couple of months from now. but I definitely do want to support that. I did used to say that the earlier form of this module that didn't do almost, the earlier form of this module, I'll cover a little bit about what it did later, but I used to say that it could work with any security descriptor if you could get the binary form or the STDL form. And I guess it's still technically true, but like the new access control entry, all that stuff, that's just not going to work right as it is now. But I will show you how you can get the security descriptor, and you can get a .NET object that would let you work with it. But all of the stuff that I'm doing, like all of these easy things, these quick shortcuts, those aren't going to work with Active Directory objects yet. But be on the lookout, because they will at some point. All right. Yeah, and so Alan says, since AD permissions are attribute and object limitable, it can be hard to translate all of that. And yes, that is the big, that's the problem that I'm running into right now. It doesn't, access control in Windows is fairly complex, and then, when you add Active Directory onto that, it's a whole new thing. So this next one, I wanted to talk about how you can control the inheritance on objects through PowerShell. So, again, inheritance really only applies to, if you're talking like service objects, there's no real hierarchy there. There's, a service doesn't inherit from a parent any of its security descriptors, but registry keys do, and file and folder do. And there are, let's see, I'm sure WMI namespaces do as well. So any of those things that can inherit, this is, I wanted to cover how you could disable the inheritance and then re-enable it. So we're going to start just like we did with the other one. We've got 3 folders. Let me run this. Let's see. I did not. Matter of fact, let me do this. New test. I don't know why this wasn't on there to begin with. This will delete and recreate it because I'm not sure what state those folders are in right now. There we go. All right. So we are going to call get ACL and get security descriptor and assign those to their respective variables. So the first thing you want to know is inheritance on, and you'll see that there's this R access rules protected property. There's also an R audit rules protected, so that would apply to the SACL. A lot of this stuff I'm really going to cover the DACL. Most of the time that's what people are interested in is the discretionary access control list. But most of this stuff, as long as you called get security descriptor or get ACL with the audit switch, you should be able to do pretty much the same thing with them. So you can see the rules are not protected, which means they are inheriting. So if the security descriptor, if that access control list on that security descriptor is protected, then it's not going to receive anything from the parent. So for the ACL object, we are going to call set access rule protection, and we're going to call it with true true. And what that means is the first parameter means enable protection, and the second one means preserve any inherited attribute or any inherited ACEs. Convert those to explicit ACEs. So we'll run that, and you'll see a little note here. If you look at the in-memory security descriptor right now, you're not going to see that anything's changed. You still see this under the is inherited column, everything shows true. And when you go to when you check R access rules protected, you'll see that it is true. To actually see the changes, you're going to need to apply the ACL. I mean, that's just the case. .NET's not going to. .NET's, when you save it out, it's passing all that work off, I'm sure, to a Windows API that actually handles the low-level act of applying the security descriptor, and then that fixes, that sets it up so that, okay, now inheritance is disabled, and let's convert all this stuff over. So now when you get the new one and pipe it to get access control entry, you will see that we have the exact same discretionary access control list, except none of the ACEs are inherited. So same thing with get security descriptor. We're going to look at the original. And I guess I just didn't realize that when I wrote this up that I'd already done assigned SD. But there's this, and one other thing I do want to note, anything out of this module, it's not a compiled commandlet. It is just a PowerShell function. It's a bunch of advanced functions. It's a script module. And the only C# code that's in there is for the platform invoke signatures. And a few of the signatures, like if they return a Boolean value, I actually wrap those in its own little function so that instead of returning Boolean, it'll return an actual exit code. But what that means is if you were to inspect an ACL, something that came from get ACL with get member, it's going to look a lot prettier than mine because I'm using these synthetic, these things that came from add member. I'm using script methods. So there's the ACL object. You can see. Let's find an actual method real quick. So you can see these methods, and you can see that, what they take, all that stuff. If you look at mine, you'll see I've made these little methods that try to behave the same way. Let's find script method. There we go. Set access rule protection. But the thing is, you can't see the types of the parameters that it takes, stuff like that. That's something else for a future release. I do plan to, the object that gets spit out of get security descriptor, I do want to make it a true, a true object so that it has, real methods that reflection. When you call get member, you can actually see what it takes. But the other thing is, I really don't plan on people using using this. Like calling the methods directly on there. There are functions that handle all of this stuff. But I am showing that, if you are used to the model of get ACL, where you get the security descriptor, make changes, and then save the changes out, that is still available. So we'll call the sd.setAccessRuleProtection. Same thing as before. When you call it, you don't see it showing the right information until you actually set it out, you actually save it out. And again, this is going to prompt because we didn't call it with force. And now when you get the information, same thing. One interesting thing to note here, this is something that I realized earlier today by accident because of the way I have a deny entry applied on, not on the parent folder, but on the grandparent of this folder. This access control list now is what's called, so there's something called canonical ordering. And that's, Windows depends on that to properly assign, for access control to actually work properly. And the way that, what's happening here, we've got a situation right now where these access control lists are not in canonical order. So the ACL object, I think I'd refreshed it earlier. So let's see, are access rules canonical? You'll see false. That's actually a huge deal. If I were to try to use get ACL right now, a method to modify this, it would actually give me an error message. If in the Windows GUI I brought it up, I would get a nice little message box that says, hey, this thing's screwed up. Do you want me to fix it for you? I came across that just by chance, and I mean, this is something that, because what was happening was, let's see, the get quick SD folder still hasn't been changed. So if you were to call get access control entry on the get SD quick, you'll see that this access denied is not here. The way canonical ordering works is generally the access denied entries are going to come before allow entries, and your inherited access denied are going to come at, your explicit entries come before your inherited entries. What's happening here is that get quick. So if you look at the path, so let's do get access control entry on get SD quick folder.ps parent. So his parent has, all right. Hold on. Let's just do this. Let's grab that folder. There, so you can see that that folder is where the it's still being the access denied. I think it's coming from C PowerShell. That is something the ACL editor will show you, that this won't, is where the entry is actually coming from. And I'm not sure. I'm guessing it walks it back to find that information out. I don't know if I'm going to go that route at some point or not. But let's go into the demos folder and take a look. There you go. So you can see what's happening is this folder, the access allowed, it's an explicit entry, so that's right. And so, you know, while this looks kind of crazy here, this is still in what's called canonical order. But when you disable the inheritance and preserve all the existing entries, it's going to take it out of that canonical ordering. And that's just something that's I don't know enough about it to know if that's like a bug, if the set access rule protection should handle that. But I came up with something real quick. And the other thing, I do want to make a note. If you get what's on the Technate Gallery, most of everything I'm showing you right now should behave the same way, but this actually is, that's version 2.0 that's out there. I've been working on 2.1. It has a pretty big under the hood change, but the experience for the user should be exactly the same. So there are a few things. As a matter of fact, I don't think this bug would be in the 2.0 version, because I actually did all the ordering myself in the 2.0 version. I'm using a different security descriptor object under the hood now that handles a lot of that for me. That's why it has the same issue here. But I do think I have a function called disable ACL inheritance, and there's also one for enable ACL inheritance. The plan, I came up with something that seems like it would fix this issue. So I'm going to test that out a little bit more, and that might be in the version 2.1 that I plan to release, I don't know, probably in about a week. So anyway, the last place we just used get security descriptor. We called the set access rule protection on it, and then we saved it out. So here are using the quick SD folder, here are the one-liner ways to do it. So get item, quick, get SD, quick folder, pipe that to disable ACL inheritance. There's a preserve existing ACES switch, and we're going to call what if. And again, you can see that by default, you see a second what if where it would have tried to save the security descriptor out, because we did not pass it an in-memory security descriptor. We passed it a directory info item from PowerShell, or a .NET item. You could also call get security descriptor on it, and then call disable it. This is the exact same command, except we're getting the security descriptor, so you can see that there is only one what if. It doesn't have that second what if command there. And this does the same thing here as well. Disable ACL inheritance. We just pass it a string path. It's going to do the exact same thing. And you can see this warning that I pop up now. It's possible for ACES to end up in non-canonical ordering. I have a switch called test reorder, so I'm going to call that with no real quick. And I do actually want to call disable ACL inheritance path get SD quick folder. And I'm passing, so you don't have to pass the discretionary ACL or system ACL switches. By default, it would do discretionary, but there is also a system ACL switch here that would work. Test reorder. So when I call this, you're going to see that it hangs. It is actually fairly slow. But now, when I call get access control entry, you will see that it is in canonical ordering. I do think there is one or two ACES that are out of order besides just that denied being switched up to the top. So in about a week or so, my module should actually have, and I'm gonna check Connect on the .NET to see if they mentioned anything about the canonical ordering. Let's see. Alan, have you considered creating a folder lock function like the protect from accidental deletion in AD? I have my own, but I'd like to see what you create. I haven't actually considered that. I mean, I could add that on. Is something to look into. So yeah, I mean, you're talking about like implementing that for doing something like that for the file system or for other secureable objects. Yeah, I mean, what would you do? Like add a deny ACE. Yeah, I'll have to look into how Active Directory does that. That would be a pretty cool thing to try to implement. I agree. Thank you. So here we're going to compare the STDL. Again, the third one is not going to look the same, so I'll leave that out because we actually do have a different ordered discretionary access control list. So you can reverse what we just did by doing the set access rule protection, and you'd call false, and then the second parameter it's completely ignored. Yeah, there's no way to preserve existing entries when you're changing it over and re-enabling inheritance. So, also this is a good note here. If you try to use get ACL objects with the version that's on the Technate Gallery right now, it's going to give you a warning and not do anything. The get ACL objects, the version 2.0 of the module just did not work with those. 2.1 does work with it though. So, you could do something like this, ACL, then you can, and this actually is going to give an error message in just a second because of the non-canonical ordering. That's how I figured this out earlier. But you could call enable ACL inheritance, or I don't know, maybe it doesn't. Okay, no, that did seem to work. Huh. So let's take a look. Now it's probably really messed up though. Yeah, you can see that you still have that deny right there, but all of our inherited entries are back. I think what it was whenever I was trying to do this. We have duplicated permissions. This is what it was. When I was calling this, I was showing that you could call something like get access control entry, get ACL folder, and then these are all objects, so you could do something like where you group on the identity reference, file system rights, ACE type, inheritance flags, and propagation flags. So that shows you we didn't have any unique, I didn't add any unique ACEs because that would show up as a count of 1 there where it didn't get grouped. So then you can filter it where the count is greater than 1, and then for each group property you can expand that back out. So we're looking for basically ACEs that are not inherited. So this shows you all those duplicated ones we had. Do this, and this will work. Calling with the what if, it'll tell you that, hey, I would have deleted all those ACEs there. As soon as you try to take the what if off, this is when you're going to get an error because it's not in canonical order. And then you can see where it tries to save the DACL out with the duplicated stuff as well. We're going to say no on that. So because the remove access is a .NET method, I don't know if it's checking for, obviously we're able to set security descriptors, all that stuff. So I don't think that the low-level operating system necessarily cares about it not being in canonical ordering, but the remove access method definitely cares. So, any questions about inheritance, or because next what I want to move into are set ACL issues / bugs. I got 3 that I was going to cover real quick. Oh, goodness gracious, I didn't realize how late it was. I'm going to pick this up. All right, so here, so basically, like when you're doing things from the ACL editor, you'll notice that if you're the owner of an object, then you can modify the DACL. So you might, if you try to, let's say that you're the owner of a file, but you don't have read and execute privileges over that file, you still can't open that and read it. But you can look at the security descriptor and give yourself the permission to do that if you are the owner, or if, let's say you're an administrator and the administrator group is the owner. Well, set ACL won't let you do that. So let's start out, we look at the owner, and you can see that it is the administrators group, and we are running this as an administrator. So we're going to create a deny ACE, and we're going to add that to that folder. And now we try to do a directory listing, and you can see access is denied. So far, so good. So now let's try to get the ACL, or get the security descriptor, which we can. Great. Let's remove the access control, or the ACE. You look at the in-memory security descriptor. You'll see that the deny for the username is gone. Then you try to set the ACL. So that should have worked, but you get attempted to perform an unauthorized operation. There is already a connect bug on this. The link was up here at the top. And I do plan to release all these. We'll put these on the website if anybody wants to walk through them. So there are a few workarounds. We still have the in-memory security descriptor object, ACL there. So you could call the .NET set access control on the actual folder object. So that would work. But let's also, that would work perfectly. But let's also show that you can do get security descriptor. You could remove the access control entry and then set it, or let's actually just call the shortcut way here. You do that, set it, and boom. No access denied when you try to view the folder now. So close that out. The next issue, and this one, I remember, when I was really new to PowerShell, this one drove me absolutely crazy. So if you are not let's say that even if you're an admin, this happens. But let's say that you're a user, you have full control over an object, which gives you the ability to change the DACL. You can't, from the ACL editor, you can change it all day. Using, with PowerShell, you can use get ACL to get it. But as soon as you try to make a change and set it, it will not work. Again, even if you are the administrator, it will not work if the owner is not you or your primary group. So, again, we've called get ACL. We're looking at this. You can see that I'm admin user and the owner of the object is administrators. So we're going to make a new ACE. We're going to use set ACL. This is going to work because I'm an administrator. The DACL says I can do this, and I'm the owner. So let's take a look. You can see that my new ACE, which was for my current principal, which is admin user, full control rights. So you can see that that's not inherited. That did get added successfully. So now we're going to use there's another module, or there's another function inside of the PowerShell access control module called set owner. So you call that. We're going to change the owner, and now we're going to just get the ACL and we're going to try to set it. Boom. The security identifier is not allowed to be the owner of this object. What's actually going on here is set ACL is trying to set the entire security descriptor. It's trying to set the owner, the discretionary access control list, and unfortunately, and that's going to be our next issue, it's trying to write out the SACL, even though this security descriptor doesn't have a SACL. You need special privileges enabled in order to change the owner. If you want to take ownership, that's its own privilege. If you want to assign ownership to another user, that's its own privilege. So what's happening is get ACL got the security descriptor with the owner, the owner that was in there, and when it's trying to set the security descriptor back out, the token for my ISE module here, or my ISE here, doesn't have the restore privilege enabled, so it's going to fail. Same exact workaround as before. You can use the set access control for the folder object. It's also a static method on the actual, I believe it's a static method on the directory info type as well. Or you can use the pack module. Get security descriptor, set security descriptor. By default, you can see it's even telling you up here, it's only trying to set right here the DACL. It's not trying to set the owner. It's not trying to set the SACL. You don't need any privileges enabled. What you could do, another workaround, people have talked about doing is you can actually enable the privilege yourself. The PowerShell Community Extensions, I think, has a function that will allow you to do that. Internally, the PowerShell Access Control module is doing that. Lee Holmes had a blog post years back, I think for PowerShell version 1, that did this. Maybe it was version 2. I think it was an advanced function. But you can do that and give yourself the proper privileges, and then set ACL will work. So another issue. This one is the biggest one to me. So if we start over again, just like all the other ones. Here we're going to set up the folder, and we're going to make sure that there are some SACL entries that are being inherited. So in here, as a matter of fact, since this was already done, you can see what I was doing here was, and let's look at this. As long as there's inherited, yes. So you can see that there isn't, and here I wanted to make sure that there is a SACL on the parent, because I'm going to show that we're inheriting audit entries, and we're going to make an explicit one as well. So here's where we're going to call get ACL. We're going to call it with the audit switch, so we get the SACL. We're going to make sure that there are some entries. You can see that there is one there. It is inherited. Let's also look at the are audit rules protected. They are not protected, which means inheritance is enabled. So here we're going to add an ACE. Again, we're using new access control entry. This does work in version 2 with the get ACL objects. So new access control entry, we're calling it with the ACE type system audit, principal everyone, folder rights full control, any access on this thing, we want it to be audited, and you can see the switches for audit success and audit failures. So we create that entry, we call the add audit rule, and again with version 2.1 you could have piped this into add access control entry as well. Then we're going to set it. That works. Let's take a look at audits on that object, and you can see that we have one that's inherited and one that's not inherited. So now we're going to call get security descriptor on it without calling the audit switch, and then we're going to just take what we just called and we're going to call, or what we just got, and we're going to call set ACL. We haven't made any changes. We're just getting the security, we're getting it and we're setting it. There's no reason, usually you're not going to want to call it with the audit switch. There's no point to do that when you're not trying to change the SACL. So now we're going to call one more time. We're going to get it with the audit switch again. And now let's check, are access rules protected? They are protected. I mean, we didn't turn inheritance off anywhere. All we did was got a security descriptor object without the SACL and then saved that back out. So how many entries do we have? Well, when we call that, we don't get anything back. It just wiped out the SACL. So when we call get access control entry, again, you won't see anything there. So the workarounds are the same as the other ones. You can call the set access control method on the folder object itself, or you can use the PowerShell access control module. By default, it is not going to, unless you have, unless the SACL is present, it's not going to touch the SACL when it tries to save out the security descriptor. Let's go into a real quick demo on using kind of an advanced feature of get security descriptor, and all this is documented in the help. I mean, there's a ton in the help on the module. I do plan to add more examples, but I think there are enough examples to kind of get you started. But the different parameters are, I think, fairly well explained. So here's an example of like if you wanted to get share permissions. So you could get WMI, the Win32 logical share security setting. You could also use Win32 share for this. You could also, if you're on a Windows 8 or higher, do get SMB share and pipe that into get security descriptor, and boom, you can see these are share permissions, not NTFS permissions. I have two shares, one called MSPSUG and one called PowerShell folder. But I need a WMI. Out of those three ways to get a share, I need WMI for that to work. On the Technet forums a few weeks back, there was somebody that had he had a Samba share, but it was a non-Windows machine, so the WMI wasn't going to work. So, get security descriptor. You normally use the path. There's another parameter set though that allows you to use this object type. And just like with almost everything in here, this is it uses IntelliSense if you're PowerShell 3 or higher. It uses tab completion. So if you pass it that path, you'll see this stuff comes up. Now you can see there's a DS object. This is what I was saying. You can get the actual security descriptor for an Active Directory object. If you stick around after the meeting for a few minutes, I'll explain kind of like how you can still view it. But by default, you're not going to see anything with that nice, pretty access and audit property. But anyway, back to this. We're interested. This is a share, so we pass that to it, and boom, you get the exact same information. But this would work against a non-Windows machine because you're directly passing it the path, assuming that the user that's running it has privileges. You can also, this is pretty cool, remote registry. And if you see the help for this, for the object type parameter, it actually gives you an MSDN link that tells you the format that you need this stuff in. But this computer's name is Magic Mini, so I can actually, this would work against a remote machine as well. You put the machine name in, and then the Hive, that's where you'd want to go to that website to see the formatting. You don't do like HKLM or local machine. It's just machine. And you pass it tell it the object type is the registry key. And have to take my word for it, but that would work against a remote machines registry. You could also do WoW64. Here's an example showing there is no software Adobe on my machine. It is a 32-bit application, so it's under the WoW64 32 node. But if you pass it this path, machine, software Adobe, and object type, this is something you probably wouldn't normally do, but it's just an example of showing that the Win32 API that this uses, this is kind of what it takes. It takes a path and the type, and you can do all that stuff directly, and it should work. So, now you can see that's the way that a 32-bit application would reference it. So that works as well. Two more quick things. These are, I really do think these are pretty cool as well. This one shows an example of changing a process's security descriptor. So we're going to start up, first we're going to check to see if there's any process called calc. There is not. We're going to start one. So let me bring that over here. Let's snap this window to the side, and let me grab this other window that I have here. And it's not letting me snap. Oh, come on now. Hold on. It just went to the other monitor. Let's see, will that work? There we go. So we just started this calc process. First thing I'm going to do, see if I can access the handle for it. I cannot. This is a separate user. This is a limited user, where the other one was admin user. Let's see if I can stop the process. I cannot. Access is denied. So let's go back over here. Let's look. We can call get process on it. We can see it. We can get the security descriptor. I really needed to, without that full window there. So here we're going to show that you could have called get access control entry, or you can expand out the access property. Oh, that's ugly. Let's call that again. There. So you can see, I showed a demo of this earlier. So you can see the ACEs for that process. This is just to show you that you can in fact call get access control entry. It's trying to squeeze it all on screen, so it looks really ugly. Sorry about that. So here we will do this. We're going to add users. We're going to give it process rights all access. This isn't necessarily a good idea, but for a demo, it'll work. Now when you try to get it again, you'll see that users have all access. So let's minimize that real quick. Here's our calc. Let's try to get the handle again. Remember, hold on. What just happened? Why? That's embarrassing. Let's try to give it directly to that user real quick. I'm not sure what's going on there. I swear this worked earlier. I know you probably hear that all the time. Unless maybe I hit, well no, we just looked at it. It is showing up there. Alright, limited user. It is definitely there. And I'm not sure what's going on there. Alright, well, I'll have to, I don't know, we'll have to see what's going on there. But I will leave you with, I like doing this. You will see some errors. Hold on, those are like system processes where you can't get, I probably should, hold on, let's do error action, silently continue. There. So there's different processes on the machine, showing you that you can view this, and you could send this to export CSV. You could send it to out grid view. The problem with sending it to out grid view is it's only going to show these columns here. You won't see like the path information or anything like that. One more thing that I really think is really cool. You can't do this with the native PowerShell stuff. Sometimes you come across a folder structure or registry structure, something like that, that you don't have access to it. You're an admin, and in the ACL editor, you would right-click on it, and you would give yourself, take ownership, and then you can see the DACL. And if you need to, you can add yourself. You can do that without wiping out the DACL that's already there. So for this one, let's see. Oh, hold on. I gotta love the providers. Get mad about that. All right, so let's make a new one. Our other user we're going to use is limited user. So let's just give it some children. Make it an actual. Give it some structure here. This is just going to call get random a few times so that we now have, under that key some, a couple children, and they have some children, stuff like that. Now we want to change the owner on all of them, because right now I'm the owner. So let's change the owner real quick. Yeah, that looks good. All right, yes to all. And now when we try to look, access denied. Because what we did here, I'm sorry, let me walk through that. We told it to go through all the children and the item itself. I sorted it descending because I wanted to work backwards. If I changed it on the parent, then I don't know that I'd be able to look underneath it. I called disable ACL inheritance. I did not call the preserve existing entries, so that basically clears out everything. There's a path. I didn't really mention this. There is a pass-through switch, so you can chain these things together like this. Pass-through means spit the security descriptor out so that the next thing on the pipeline can take it. Add access control entry. We're going to give that alt user, which is limited user, that's who we're going to add an entry for. We're going to give him full control, and we're going to pass that through so that set owner can set the owner to that user, pass that through, and then set the security descriptor. Now, set owner actually has an apply switch on it. The problem with that is it literally will only set the owner if you apply there. So we wanted to, calling set owner against an in-memory security descriptor changes it on that security descriptor, and then set the security descriptor is smart enough to know that that owner has changed from what the original security descriptor was. So go ahead and try to set the owner at that point. So after doing that, the net result is I'm not the owner, so I can't get the security descriptor. This would actually, this part right here would work. There is something else I'm going to add to version 2.1, is that like right now, well, I'll explain it as I get a little bit further. So we can take ownership of the that key, that parent key. So we don't know what even exists underneath it. If this was something we came across with PowerShell, but we can set the owner, and now we can get the security descriptor. Now, right now we have to use the direct path. By the time version 2.1 goes live, it should behave. This set owner being able to just take the path directly like that, that's new. I have a little helper function that does all this stuff, and it by default tries to call get item, so that causes stuff to bomb out. Earlier today was when I changed set owner. That's not needed for registry and file stuff, so I'm gonna take out that call to get item by default. But now we can get the security descriptor. We still wouldn't be able to, we still can't do a directory listing. We're going to get access denied because we don't have access on it. But since we are the owner now, we can change the DACL. So, this is, I don't have a way yet. I'm planning on having something that would do, so you can implement the apply this to all child items yourself. And that's kind of what this is going to do. To implement the add this to all child, apply this to all child items, you would pretty much just call a remove access rule, and I have a switch to remove all access entries or all audit entries. So you would call that and then call enable ACL inheritance, and then boom, you've basically made the child look just like the parent does. I'll probably end up, making a little function that'll do that. This is showing a function, it's a script block, which is, it's still a function, it's just a function without a name. And what this thing is going to do is you're going to feed it a path, or actually, will that work? I just modified this. I wonder, I might need to just change that to args instead of arg0. But we're going to take that security descriptor, and what it's going to do, we're going to pass it the registry path, and what it should do is, since we can't do a get child item, because even after we've changed the security descriptor on it, we can do a get item. We can't do a get child item because we still won't have permission on the children. So we get the actual key item itself, and we're going to, old school, we're going to, or manually get all the subkey names, get another set of paths, and then pass that back through, call the script block on it. Okay, yeah, this will work. I see what's happening. So when we call that, you can see yes to all wouldn't actually work here because so we're going to have to go through each one, but you can see that it's walking down, setting the owner, and adding an access control entry to give the current user full control. And if I would have put force on there, then this wouldn't be prompting, so this would have been silent. It is a way to break through and do all that. And now we can view everything again. So, I might end up having like a set owner, like putting a switch that tells it to do it to all child items. And if it's something that PowerShell, if get child item would work on it, and for registry keys, again, I'll probably have to do something similar to this, then I might have it automatically apply all that. And it is 10 o'clock. One more thing before we go, something else that is coming in version 2.1. I'm planning to do mandatory integrity levels. Might not be for 2.1. I mean, I've already got the code that will essentially do that, so you can view that on a file. The other thing, effective access. That is something I do have like a little demo here. Hopefully, it won't bomb out like the process, changing the process entries. But get effective access. Let's do I still have like a folder? Yeah. So folder, get effective access. By default, it'll show it for the user. And this isn't what the final stuff's going to look like, but so the operation completed successfully, great. The granted access, full control for this user. And I'm going to have a switch. When you do this from the GUI, from the ACL editor, it actually doesn't tell you what your effective access is. It shows you all the different enumerations for the access mask, and tells you, you get like a check mark or an X to say you got that or you didn't. So list all rights. So you got something that looks like that, and you can see, basically I get all of them. I had full control. That makes sense. If I were to say for the principal, yes, boom, you can see. And again, this is where up and just have like a allowed true false type thing. But you can see this is actually normal here. Access denied, granted access was 0. So basically for there was a desired access that's not showing here. That's where it would have shown that friendly name. So that's where I'll be able to say, hey, you got for execute, nope, you didn't get that. For modify, you didn't get that. Let's find something like users probably. See, here's where you can see that they've got all those. And again, the information for what the friendly name for that was, that is actually contained in the results. I'm just not, I don't have the actual formatting put out for this yet properly. But that will be in version 2.1. Look for that, like I said, in about a week, week and a half. Since there was a big under the hood change, I do have a good bit of testing to do, but it does make 2.1 will be a ton faster when you're doing other stuff. And I really didn't even go into how you can do bulk copies. You can take a single ACE and add it to 100 different objects if you want. You can do, and hold on, that was get effective. The other thing, I really just focused here on folders and a few registry things. I mean, you can still do stuff like get service bits, get effective access for users. Basically users, and this is probably because I don't know if that comes by default or not, but you can see users have start and stop, and that's it. Let's look at administrators. Boom, they can do all that, and I would have to see, again, you can see it's not completely done, but it is very, very, very close. And if you're interested just, what are administrators' effective access, full control, bam. So any questions? And I'm actually I'm willing to stay up for another 30 minutes if anybody just wants to talk, and if you have any features that you'd like to recommend. That's here. Let me put my Twitter handle in here. If you have, I get notifications on my phone. I don't really tweet much, but I would see if you tweeted something at me. And there's also on the Technate Gallery, there's a question and answer section. And I do plan to do some blog posts about the module that don't really show how to use it, but actually show some of the things that I did inside of it, like the stuff I did with dynamic parameters. I'm fairly proud of that. I mean, you get these crazy-looking syntax things when you call get command, because there are so many of those access right parameters. But anyway, there's some cool stuff I do with dynamic parameters that I plan to blog about. I have some a little bit of that stuff done. But if you do like it, I mean, go out, download the version that's out there. If you really like it, rate it. There's not too many ratings on there yet. I mean, it's got about 200 downloads right now, so I'm not expecting it to go super huge or anything like that. But I would appreciate it, though, if you have any feedback, if you find anything that's not working, definitely let me know that. But if you find something that you think would make it better, then there's not enough people using it to where I would be like inundated and not be able to listen to feedback. So with that, if anybody wants to unmute and talk or